Welcome to another episode of MrLopezClasses.com. This is the episode number 3 of the chapter 13. In this episode, we are going to disassemble the fuel injection pump. We are going to check internally what happened with the fuel injection pump and how those parameters like RPMs and load are administered internally in the fuel injection pump. This is the typical configuration of the fuel injection pump. The fuel injection pump have the priming pump or fuel supply pump, and internally this is the main shaft or camshaft, because internally is a camshaft, and this is the small engine. You remember, this is the small block. Those are the plungers per each cylinder, and here is located the governor. This is the governor, and this is the throttle lever, and this is the aneroid valve to control the administration of the atmospheric pressure. We have the idle to stop, and this is basically the mechanical fuel injection pump. We are going to disassemble this pump, and we are going to check internally what happened with that pump. This is the video that I prepared for yours. Okay, we are going to start with the rotary mechanical fuel injection pump. This is considered a low pressure pump. Rotary mechanical fuel injection pump. You remember that's the input of the fuel enter over there, and those are the outputs. The outputs per each cylinder. This is the handle for the RPMs. This is the bolt for idle. This is the bolt for idle. The head of that bolt is a drill head. You can pass the safety wire. You remember in our class of introduction to marine engineering, I explained the procedure to install the safety wire. Okay, that bolt is for idle, and you have the other one for wide open throttle. Okay, you can administrate both of them, idle and wide open throttle, with those bolts. And this is the handle for the RPMs. All right, the fuel enter over there. Some fuel goes to the injectors, but the other fuel return. Remember, other fuel return, and this is the return line. This is the return line connected with the return line of the injectors. Okay, this is the body of the pump. This cable, this bolt is a very important bolt. That bolt, once again, the head of that bolt is a drill, and you have a safety wire over there in order to avoid that the people touch this bolt. With this bolt, you regulate, you calibrate the output pressure of the fuel injection pump. Never cut this safety wire. Never touch this bolt, because you can produce catastrophic consequence. My friends, never touch that bolt, especially if the engine is running, because you can destroy your hands. It's dangerous. Okay, never touch that bolt. That bolt is moved for the people on the machine shop when you send the fuel injection pump to the laboratory to be calibrated each 1,000 hours. Around each 1,000 hours, you need to calibrate the fuel injection pump and the fuel injectors depending on the manufacturer specification. When you send the pump to the laboratory, they remove that safety wire and they administrate the pressure, the output pressure of the pump. And this bolt is only for professional technicians. The same like this. This is the aneroid. This is the aneroid valve. This is the valve that administrates the input of the atmospheric pressure. Okay, that one have another safety wire in order to avoid that the people move the pressure on that pump. Okay, never touch this. Never touch this. This is only for the machine shop. Okay, exactly, the safety wire over there to administrate the pressure. Never remove that. Exactly the same like this one, the intake of air. Both of them have a safety wire. All right, never cut those wires. Important. Okay, that's the window to verify if the engine is on time. If you remember, in the previous episode I explained that this corner should be aligned with the mark internally. in this particular case, the mark is a little off with respect to the center of the triangle. Okay, it's because it's moved 6 degrees before top dead center. You remember that particular engine should be calibrated 6 degrees before top dead center. Okay, I explained that procedure in the chapter dedicated to the timing calibration. Okay, this is the window to calibrate the timing. You have 2 marks to calibrate the timing. This is the second mark. Okay, this is the mark for 0 position. And higher is the mark for 6 degrees before the top dead center. Yeah. Okay, those are the marks. This is the pump. The other pump is the inline mechanical fuel injection pump, low pressure pump. This is an inline pump. Okay, and we are going to check what happened internally on that pump. Exactly, this is the pump. Remember, this is the mini block, and this is the governor. The mini block and the governor. Okay, the mini block internally have the camshaft, and those small cylinders or plungers, those small cylinders, and this is the output with high pressure per each injector. This is a mini engine. This small camshaft is a replica of the big one. Exactly like this. This small camshaft, this is the small camshaft of the fuel injection pump, and this is the big camshaft of the block of the engine. Both of them have the same configuration according with the angle of the lobes. Right? Okay, this is the pump. This is the this is the priming pump. Normally it's bolted on the side of the fuel injection pump. The fuel enter over there, the fuel continue here, and right now we have fuel entering in each small cylinder in each plunger. This is the plunger. Alright, that's the input. And this is the input, the feeding for the input. The fuel enter over there and enter in that small hole. Yeah, the fuel enter over there, here, and enter in this small hole. And the fuel continue for the second one, for the third one, for 4, for 5, for 6, for all the cylinders. And in the other side of the plunger, there is another hole, and the other hole enter in other manifold for return. Okay, this is the manifold for intake. And here is the manifold for return. Okay, this is the hole for return, and this is the manifold for return, and this is the return. Okay, this is the situation. This is a top view that I prepared of the inline mechanical fuel injection pump. Alright, this is the feeding for intake, and internally in the small mini block you have this cavity for intake manifold, for supply manifold, and the fuel enter in the plunger, in each plunger, in the small hole of each plunger. In the other side, the plunger have another hole that return fuel and return into the fuel tank. Alright, this is the top view. This is the input over there, the manifold is over there, and in front here is the return. Input of fuel over there, and return, and the return finish over there. Return over there. Okay, this picture is nice because this is the input and this is the return. Okay, those are the plungers, that's the return. Exactly, and this is the handle for the RPMs. Right now we are going to talk about that handle. This is the handle that is connected with the console, with the control. How the pressure is multiplied and how the RPMs are advanced or retarded. More RPMs, less RPMs. Now we are going to check how is internally the procedure to increase the RPMs And how is internally the procedure to increase the pressure dramatically? Because remember, the input pressure is around 20 psi and the output pressure is around 3000 or more psi in this particular pump. Okay, those are the plungers, all the cylinders. I'm going to remove one. Perfect. All right, one hole in front of the input. Perfect, in front of the input, and other hole in front of the return. Perfect, in front of the return, and the return goes into the return of the tank. This is the input. Okay, look internally what happened. I have a plunger that is going up and down. This is a small piston, the plunger, and you have one hole here for intake of fuel and other one in the back to return. But additionally, the plunger have two functions. One function is the vertical movement up and down to compress the fuel, but the plunger also rotates a little. Depending of the rotation, the RPMs increase or decrease. Increase or decrease. This is possible because internally all the plungers can rotate at the same time with a special rail. The rail is connected with the governor, and the governor accelerate or decelerate depending of the load. Depending of the load on the engine and depend of external conditions, the governor accelerate, and all the plungers move like this at the same time, or like this, or like this, or like this. Exactly. This is the plunger. The plunger have two movements, up and down, and rotational. It's some degrees. It's like a 6 degrees or 7 degrees, the rotation. It's a little. Okay. And in the bottom, have a quadrant. Exactly. This is the plunger. Right now we are going to check the construction. And in the bottom, look. The plunger have one special cavity. Right now we are going to check that cavity, that groove. What happened with that groove? Why in one position allow the input of a lot of fuel, high RPMs, and why in the other position allow the input of low amount of fuel, low RPMs? Wonderful. And in the bottom, this plunger have a quadrant that enter in this capsule, and this capsule have this pivot, and the pivot enter in the rail, and the rail goes up and down like this. Let me show to you. Okay, this is the groove for the amount of fuel, and this is the pivot on the capsule. This is the pivot. Yes, the plunger enter on the capsule, exactly, and move like this, exactly. This is the quadrant, that small area, that small rectangle, enter in this, in the capsule, and the capsule move back and forward, and the acceleration increase or decrease like this, exactly. And now the capsule enter in the rail, look, and goes more acceleration, less, more, less, more, less. Right now I am going to explain later a better view, top view of that movement, the movement of the capsule and the plunger. Exactly. In other words, the plunger is moving like this for acceleration, more fuel, less fuel, and up and down to send the fuel at high pressure to the combustion chamber. Up and down to compress the fuel, and rotational for more RPMs, less RPMs. Too simple. Exactly. This is the groove. The groove normally is in front of this hole. The plunger have one groove in front and other one in the back to return the fuel. One in front and other one in the back. Right now I am going to show to you. Alright. Correct. The piston move up and down, and other one in the back. I have another plunger, big one, of a big fuel injection pump. In this one we are going to check easily where the fuel enter for input and in the back return. Okay, this is a big plunger. The plunger is basically one liner, the external cylinder, and one piston or plunger. Alright? Okay. This is the liner, and this is the plunger. And one hole here for input of fuel, and other hole in the back, 180 degrees in the back for return. Alright, that's the plunger. And on top they have the body of valves, because on top when the plunger is going up, they the cylinder have a special combustion chamber with the exhaust valves and return valves. Exhaust valves and return valves. Okay, those are the exhaust valves and those are the return valves. Yeah? Exhaust and return. Exhaust and return. Perfect. Exactly. And this is the body of valves. Right now I am going to explain. I prepared a nice video in order to explain internally what happened in this body of valves. Okay? Alright, this is the hole for input. And this is the hole for return. Input and return. And those are the O-rings in order to produce perfect seal in both compartments, in the intake manifold and in the return manifold. It's like a mini engine. Okay, and the plunger. Alright, look at the plunger. Look at the groove. Ah, nice. It's like this. It's like this picture. This is the hole. This is the hole. And this is the groove on the plunger. With a big, it's like a big triangle. With a big area in the base of the triangle and a short area on top of the triangle. You have one groove in front of the plunger for input of fuel, and in the back 180 degrees in the back, other exactly the same for return, other triangle for return. And you have in the cylinder, in the sleeve of the plunger, you have one hole for input. This is the input. This is the housing of the fuel injection pump. That's the feeding for input. The fuel enter over there. This is the housing. You remember that cavity on the housing. And this is the hole on the body of the plunger. And here is the plunger with the one triangle to receive the fuel and other triangle to return. Exactly, and this is the return. Okay? This is the plunger, and the plunger is moving up and down. Up and down. Okay, let me check the movement of the plunger. Okay, that's the hole for input, the hole for return in the backward. The hole for input is a little higher than the hole for return. Let me check in the video right now. One hole for return and other for input. And this is the plunger. Okay. Let me show to you what happened. Okay. What happened? Exactly. This is the triangle. You see? It's a triangle. One in front, one triangle here in front, and other 180 degrees in the back, exactly the same triangle. One triangle in front of the hole for input, and other triangle in front of the other hole for output. You see, the hole for input is a little lower in comparison with the hole for output. Alright? Right now I am going to check why is one a little down and the other a little high. Yes, because if I want to accelerate maximum acceleration, I want that the piston be located in the high area, to receive the maximum amount of fuel and produce high RPMs, and I need that the return be located in the small area. Yeah? In the opposite, if I am in idle, I want that this hole be located in front of this small area, idle, and the return located in front of the big area for return. Simple! For that reason, the plunger have this movement, and this and this. Alright, this is the procedure. Exactly. This triangle is in front of one hole, and the other triangle in the back in front of the other hole in the back. Exactly. One hole, a little lower, and the other hole a little up. Simple, exactly like the picture that you have on the screen right now. And the plunger have the grooves or triangles to allow the fluid for input, and in the back the fluid for return. More fuel, less fuel. Less fuel on top, more fuel in the bottom. Look, and the capsules move like this. More and less. More and less. You like it? It's not complicated, no? Okay. Right now we are going to check what happened on top of the plunger, where the valves are located. Because what happened when the plunger compressed the fuel? It's supposed that you have a check valve over there that allows that the fuel goes with high pressure into the injector. Yes, on top of the plunger you have a body of valves. Depending of the fuel injection pump, there are bodies of valves with a regular check valves with a spring and ball, and there are other ones with a stainless steel element with flaps, like in the air condition system, the compressor of the air condition system. Pretty similar. Alright, we are going to check what happened. Plunger, body of valves, mechanical low pressure pump. Okay, this is low pressure. Alright, we are going to disassembly on top of the plunger, and we are going to check how is the valve. This valve in particular is for both directions, input and output. Okay, exactly. We remove the body of valves. We found springs similar to the injectors. We found a spring, and we found washers. Yes, we can calibrate. When you send the fuel injection pump to the machine shop, they replace those springs and those washers for new springs and new washers in order to produce more pressure. And additionally, they calibrate the position of the plunger. I am going to explain later the position of the plunger, because the plunger can be adjusted on top, and you can calibrate the height of the injector with chims. All right. Exactly. Those are the washers to calibrate the pressure. Those are the elements that they replace. And this is the double action valve, double direction, double way. This is a double way valve. That valve is a perfect design. When the fluid is going in one direction, open in that direction, but block the return. And when the piston is going down, allow that the fluid return. That's wonderful. Correct. This is the valve, and this is a pressure washer, copper pressure washer, and this is the double action element of the valve. Normally they replace that washers, and they replace. This is a cylinder. This is the liner of the plunger. This is a perfect hole cylinder. This is the liner, and this is the plunger. Normally they replace the plunger, and they replace the spring, they replace the washers, and right now recover the pressure. Exactly, this is the procedure to put in back the system. You put in back the washers, you replace the washer, or you added additional chims or washers, and after that you locate again the spring. Perfect, you locate again the spring. Correct, you put the washers in the position, the spring, exactly, and the injector is ready. This is the plunger. This is a low pressure. The body of valve for a plunger of an other injector, other plunger for high pressure system. It's the big one. This one, exactly. This is the body of valves. Internally is exactly this picture. It's exactly this picture. This is the plunger. You remember? This is the liner. This is the liner. That one. This is the liner with one hole in one side, one hole in one side, and other hole in the other side. This is the liner. And the plunger is that one. That one. This is the plunger that is going up and down. And on top, this is the body of valve. This element. This element. This element. It's clear, my friends, that the body of valve, in between the body of valves and the sleeve, the cylinder, you have this stainless steel element with flaps, some flaps. When the plunger is going down, this flap open and allow that the fuel return. When the plunger is going up, this flap open and the fluid enter in the combustion chamber and goes up with high pressure into the injector. Nice, no? This is that system is pretty similar that the system used in air conditioning equipment. Each manufacturer have different type of valves. This is only for information. Probably you never need disassembly an injector. You send to the machine shop, they replace, they repair, they calibrate, and you receive those fuel injection pumps and those injectors properly calibrated. This is only for information because I want that you understand what happened internally in each element. If you understand what happened, you can understand for what reason I have lean mixture, for what reason I have rich mixture, for what reason at some RPMs the engine try to stop. If you understand all the elements, you know what happened internally in the engine. You don't need visit the engine, probably only with the questions and the oil sample report and the coolant sample report, you can do the diagnosis. Alright, my friends, this is the body of valves of the plunger for a high pressure pump. Okay, we are going to continue. This is the body of valves. Exactly, and those are for input and those are for return. Those are for input and those are for return. Exactly the same. Okay, now we are going to try to understand how the governor works, the magic element that accelerate, increase the acceleration or decrease the acceleration in a mechanical fuel injection pump. Okay, we are going to disassemble carefully the governor and we are going to try to understand how accelerate more RPMs or less RPMs. Alright, this is, okay, that the mini block and this is the governor. Correct, mini block and governor. Okay, okay, my friends. The governor internally have a mechanism, it's a simple mechanism, but that mechanism is lubricated with engine oil. My friends, in the mini block, everything is lubricated with fuel. Remember that the diesel have a lubricity abilities. Diesel is oil, right? The mini block is lubricated for the diesel. And the governor is lubricated with engine oil, motor oil. The oil used on the main engine enter here, and return in the bottom of the governor into the oil pan. Okay, this is very, very important. Oil enter here and oil return. Now we are going to disassemble. The housing of the governor. Okay. To disassemble the housing, we are going to use those sockets appropriated. And now the housing of the governor is free and we open the governor. Okay, my friends, let me explain something. The camshaft of the mini block, in one end, the gear of this small camshaft is connected with the gear of the camshaft of the big engine and with the gear of the crankshaft of the engine. You remember the timing? Okay. The gear of the mini block, the gear of the fuel injection pump is connected with the gear of the camshaft and the gear of the crankshaft. Alright. The other end of that small camshaft in the mini block have a counterweights. According with the RPMs, the counterweights open or close. Open or close. Open or close. When the counterweight open, push this element out. When the counterweights return, this element goes in, out and in. And in the other end of the mechanism, this element engage with the rail. The rail for the plungers. You remember, more fuel, less fuel. More RPMs, less RPMs. Like this. Follow me. Like this. enter over there into the counterweights, enter into the counterweights, that's element, and when the counterweights open, press this one, and this element move the rail, more RPM, less RPM. Check this diagram, the diagram that I have on the screen. Look, when the RPMs on this element increase, those counterweights open, and this element goes out. If this element goes out, the link move the rail backwards, and the RPMs decrease. When this element decrease, this element goes in, this element goes out, and the rail goes in the other direction. More RPMs, less RPMs, depend of those counterweights. Those counterweights open or close, depending of the RPM of this camshaft. The RPM of this camshaft depend of the RPMs of the main engines, because the gear of the main camshaft on the engine is connected with this small gear of the fuel injection pump. Bingo! This is the procedure to increase the RPMs and decrease the RPMs. It's a simple mechanism. This element connected with the counterweights, and the counterweight push or pull, and the link over there push or pull the rail, and the plungers goes like this, more fuel, less fuel. You remember, all the capsules move like this and like this. This is the rail, and this is very, very simple. Look, the counterweights open and close and push or pull this element, and this element goes exactly up and down and push the rail. That's simple, my friends, and this is the procedure. This is the procedure to activate the governor. My friends, this is all the theory related with the fuel injection pumps. It's not complicated. Okay, in the next episode, I am going to explain the common rail systems. It's very simple because we are going to use one of these pumps, the pump for high pressure. There are two possibilities, mechanical or electrical pump, vane pumps. This is for common rail, and this is the next episode. I hope you enjoyed the episode. Visit my webpage, and in the webpage you found a lot of videos related with this system, with fuel systems and with diesel engines. Thank you.